In this chapter, you will learn about the concepts of momentum. We use the term momentum in many different contexts in our everyday life, such as in finance, sports, politics, and many other different contexts. So we use the term momentum when something has a tendency to keep going. In physics, we use the term momentum when an object has tendency to keep moving. In other words, we can say that momentum is measure of inertia of motion of an object, meaning greater the momentum of an object, harder it is to stop the object. Now let's talk about the factors that affect the momentum of an object. So let's consider a Big Mac truck and a small car. So if they are moving at same speed, which one would have a greater momentum? Or in other words, which one would be harder to stop? So we see that from our everyday life experience that it would be harder to stop a big truck, right? So looking at this again, so it would be much harder to stop the big truck compared to the small car. That means greater the mass of an object, harder it is to stop. Or you can also say that greater the mass, greater is the momentum of the object. Now let's look at another example. There is a bullet and a baseball moving at some speed. So we know that the speed of the bullet is much higher than the speed of the baseball. So if I ask you which one has greater momentum, in this case it's much harder to stop the bullet compared to the baseball. That means the bullet will have much larger momentum than the baseball. So that implies that greater the velocity, greater will be the momentum of the object. So from these two examples, we can say that momentum depends on mass, or in other words, greater the mass, greater is the momentum. And momentum also depends on velocity, meaning greater the velocity, greater is the momentum. So we can combine these two results and get the expression for momentum, which is P equals mv. And we know that velocity is a vector quantity, so momentum is also a vector quantity. So we can write vector P equals mass times vector v. Because momentum is the product of mass and velocity, so its unit is kg meters per second. So now let's talk about change in momentum. So what you need to do in order to change the momentum of an object. In the picture you can see that there is a big box and the box is initially at rest. So what you need to do in order to change the momentum of that object. We know from our everyday life experience that we need to apply some force in order to change the momentum of the block. Now, it's not only the force that affects how you change the momentum. So let's see an example. So we have two cases. We'll be applying same amount of force, but in the first case we'll be applying force for shorter time, and in the second case we'll be applying force for longer time. So we'll see which one will have greater change in momentum. So we see that in the second case, where we apply the force for longer time, there is greater change in momentum compared to the one in which we applied force for shorter time. So we can conclude that if the force is applied for shorter time, there would be less change in momentum. And if we apply force for longer time, there would be greater change in momentum. So in summary, change in momentum depends not only on force, but also on how long the force is being applied. Again, longer the duration of force, greater is the change in momentum. So the force that is applied over certain time duration is called impulse. So impulse is force times time duration. Okay, impulse is denoted by letter J. So J is force times delta t, where delta t is the time duration. Since impulse is the product of force times time, force is measured in newtons and time is measured in seconds. So the unit of impulse is Newton second. Now let's talk about a very important theorem called impulse momentum theorem. Impulse momentum theorem tells us that if you want to change momentum of an object, you need to provide impulse to the object. Let's derive an expression for impulse momentum theorem. We know from Newton's second law, F equals ma, and acceleration is final velocity minus initial velocity over time. Now we can distribute mass to these velocity terms. So we get F equals mv final minus mv initial over delta t. Now we can get rid of delta t on the right side by multiplying both sides by delta t. So F delta t equals mvf minus mvi. Now we know that mv is momentum. So that means mv final is final momentum and mv initial is initial momentum. So we can write this as F delta t equals final momentum minus initial momentum. So final momentum minus initial momentum is change in momentum. So J equals delta P. That means impulse is equal to change in momentum. So that's what impulse momentum theorem is. Again, impulse momentum theorem tells us that when you apply some impulse to an object, the impulse changes the momentum of the object. Or in other words, you can say that in order to change the momentum of an object, you need to apply impulse to the object. There are many applications of impulse momentum theorem. So let's look at this example. In this example, Abby splits a stack of bricks by bringing her arm and hand swiftly against the bricks with considerable change in momentum. So before hitting the bricks, Abby's hand has significantly large momentum, and when she hits the brick, the momentum of her hand goes to 0. So there is change in momentum of her hand, and to change the momentum of her hand, she needs to impart impulse. So there are different ways she can impart the impulse. So one way is by applying larger force over shorter time period, or she can also apply smaller force over longer time period. So in this case, she briefly touched the brick. That means she's applying the force for a very brief time. So when she applies the force for shorter time period to impart the impulse, the resulting force would be really large. That results in huge impact force. We can conclude that decreasing momentum over a short time period produces a large force. Now let's look at another example. When you're driving your car on a freeway and if your brakes fail, and if you have two options, one is to run over a pile of haystack and to hit on a concrete wall, then you would choose to hit a pile of haystack. And the reason behind that is you want to change the momentum of the vehicle from some higher non-zero value to zero momentum. And in order to change the momentum from some large value to zero value, you need to impart impulse. And there are two ways you can impart impulse. One is by applying smaller force over longer time period, or applying larger force over smaller time period, as shown in the figure. So in the first case here, when you run over the pile of haystack, you're applying smaller force over longer time period. And in the second case, when you're hitting on the concrete wall, you're applying larger force over smaller time period. Okay, so when you apply smaller force on the haystack will also provide smaller force back on the vehicle from Newton's third law. So you get equal and opposite force from the haystack. So we can say that decreasing momentum over longer time produces a smaller force. Here is another example. So in boxing, the boxers often ride with punch to decrease the impact force by elongating the time of contact of force. If you move towards the punch, that decreases the time and increases the force, which is not what you want.